All right, so the last problem for section 5.3 is we are going to solve an inequality based on a rational equation. Now, we have solved inequalities when we had absolute values. We solved inequalities when we had quadratics. We've already done this twice. Our process is going to be exactly the same. The first step is to always solve the equation. Okay, so step number 1, solve the equation. Now, we did that in a previous video. It was our first video of this section, so you can go back and watch that. When we solved the equation based on these, remember, don't try to clear fractions here because you don't know if this is positive or negative. You don't have any idea what to do with the sign. That is a mistake, and it's going to lead to the wrong answer. So the first thing, solve the equation. We already did that in a previous video. We got 1. The second thing, and we've done this before. Now what you're going to do is you're going to use a number line to represent the domain. Well, I need to then figure out what is the vertical asymptote here. Remember, the only thing that limits the domain of a rational function is when is the denominator 0. So I'm going to take my denominator, 2x plus 1. When is that equal to 0? I subtract 1. I divide by 2. And I have a vertical asymptote, if we're thinking about the graph, at negative 1/2. Now I'm just going to put all that information together on the number line, and I'm going to check on the number line. And then we're going to come up with the intervals that solve both of these inequalities. So here's my number line. Okay. I'm going to put the point of equality on here, which is 1. That's equality. So I'm just going to write that word so that we remember later. And then negative 1/2 is not in the domain. Now, I don't want you to get confused later when we answer the question and think that this is a point of equality. So I encourage you to go ahead and draw a nice asymptote there so that you remember that negative 1/2 is never part of your solution set. And now what I'm going to do is I'm going to pick values, and we're going to see in each of these intervals, do I get a result that is less than 1? Or do I get a result that is bigger than 1? And we're going to see. So this first interval is from negative infinity up to negative 1/2. So I'm just going to put in the number negative 1, and we're going to see what happens. So when I come back up here to the top and I put negative 1 in, now I don't have a lot of board space. I apologize for that. I'm not super equipped to be isolated at home. When I put negative 1 in, I've got negative 1 plus 2 in the top. 2 times negative 1 is negative 2 plus 1 in the bottom. So that is 1 over negative 1, and 1 over negative 1, that's negative 1, that is less than 1. Okay, we're comparing to positive 1. I got a negative 1, so we've got less than. The next interval, I need a value between negative 1/2 and 1. Well, my favorite value is 0. So I'm going to plug in 0 to my fraction up here, so I'm going to erase. And when I put 0 in, 0 plus 2 in the top, 2 times 0 is 0 plus 1 in the bottom. That gives me 2 over 1, and 2 over 1 is bigger than 1. So I'm going to put a greater than right there. And then I need a value in the interval 1 to infinity. So I'm going to put in something like 4. It doesn't matter. Anything that is bigger. So when I put 4 in, here's what I get. In the top, 4 plus 2. In the bottom, 2 times 4 is 8 plus 1, and I get 6 over 9. 6 over 9 is 2/3. 2/3 is less than 1. So what we did, just to remind you, we've picked a representative in each of the 3 intervals. These are not the endpoints. They are just a value from that interval. And we saw in this interval, the fraction is less than 1. In this interval, it's bigger. In this interval, it's less than. So now, at the very end of the problem, I am ready to answer the question. So here goes. Taking into account my number line down there, when is the fraction less than or equal to 1? Well, I see it's less than in this first interval, and that first interval is negative infinity to negative 1/2. We always put a parenthesis at infinity. I know I have equals here, and this is why I recommended you do it. There's an asymptote here. Negative 1/2 is not a point of equality. It's not in the domain, so I'm going to put a parenthesis there. And then I've got a less than right here in the interval 1 to infinity. Again, we always put a parenthesis at infinity. And this is a point of equality. I'm concerned about that, so I put a bracket at that side. Okay, so let me just neaten this up a little bit. I'm sorry I don't want this to be confusing at all, so I'll get rid of that little squiggle. And that is the solution to the less than equation. The solution to the greater than equation is right here in this middle interval. So it is from -1/2 to 1. -1/2 is an asymptote, so you always put a parenthesis at an asymptote. And then since I don't have an equality, I do not care about the point of equality. I put a parenthesis there. That is the process to solve an inequality. Later in this chapter, we will solve inequalities that involve radicals. So get good at being able to solve inequality that involves a rational. Take care.